linear speed and angular speed. Define muna natin si linear and angular, no? Radian measure and arc length can be applied to study of circular motion, or to the study of circular motion. In physics, the average speed of an object is defined as average speed is equivalent to the distance traveled over time elapsed. Again, average speed is equivalent to distance traveled over time elapsed. Okay. So, average speed. Take note of the symbols used here, ha? Take note of the symbol used here. So, again, we'll be using theta to denote the central angle here. And then we have r, the radius r. And assuming this is our starting position, so we'll denote this as, or when there's no motion yet, no? Kaya yung time natin is equivalent to 0. Okay, and upon traveling a certain distance is there already some time na nangyari. Okay, upon traveling, no, at a certain distance, ibig sabihin, nag-count na tayo dun sa time natin. So, it's a non-zero value. Okay? Now, suppose that an object moves along a circle of radius r. An object moves along a circle of radius r. Okay, so you just have the object only swept out the circumference, no, of the circle. Okay. Now, traveling a distance s over a period of time t, as in the figure above. Here's the figure. So the object here will travel at a certain distance s over the time t. Then it makes sense to define the average linear speed denoted by v of the object as the linear speed v is equivalent to arc length over time. Yung linear speed natin, linear speed, kung gaano kabilis natin tatakbuhin from our starting point here to our end point here. This is the arc length s and the time t here. Okay, that is how we determine the linear speed of an object. Arc length over time. And the angular speed. Angular speed. Magkaiba yun, ha? Angular speed and the linear speed. When we say linear, you just have to travel at straight line. So the same thing I told you last time. Kapag kinuha natin from this point up to this point at in-stretch out natin yung curve, it will just become a straight line, di ba? So, linear yung makukuha natin doon. A straight line. And the angular speed that we've been talking about here is kung gaano kabilis mapo-form yung angle, kumbaga, no? From this initial side up to this terminal side. Okay, ito na tayo. Angular speed. And we use the symbol. Anong symbol to? Wait, hanapin ko yung symbol. That is Greek letter omega. Angular speed is equivalent to central angle theta over time. Central angle theta over time. Angular speed gives the rate at which the central angle swept out by the object changes as the object moves around the circle, and it is thus measured in radian per unit time. Okay? Yun yung measurement ng angular speed natin, radian per unit time. Linear speed is measured in distance units per unit time. For example, feet per second. Okay, distance over time siya, no? Distance over time. Now, the word linear is used because straightening out the arc. This is what I've been telling you. Because straightening out the arc traveled by the object along the circle results in a line of the same length. So that the usual definition of speed as distance over time can be used. Distance over time. Yung typical definition natin sa physics, no, ng speed, distance over time. We will usually omit the word average when discussing linear and angular speed. Okay? Tatanggalin lang natin. Instead of saying na average linear speed and average angular speed, we can just drop the term average. So, this is the relationship. How can we relate angular and linear speed? Since the length S of the arc cut off by a central angle theta in the circle of radius r, we have the given definition here. Diba? From the definition of arc length, yung ginamit natin in solving for the arc length and solving for central angle kanina, we see that the linear speed v is equivalent to arc length over unit time. Okay? And we can actually use a definition of arc length in place of the arc length. Diba? We just substitute r times theta in place of arc length. Nakuha nyo siya? Nakuha nyo yung point natin? Again, we just replace S here with its definition, R times theta. Okay, so we have, once again, R theta over time. So that gives us theta over time times R. Theta over unit time times R. And saan natin ito nakita? Saan natin makikita tong value na yan? Okay? That is your angular speed. Theta over time. See? Theta over time is basically our angular speed. So therefore, for we to be able to find the linear speed v of an object, we can just multiply the angular speed omega times and the radius r. Okay? That would be their relationship. Example tayo. I think it's better if we could illustrate the given problem. Ayan. Drawing tayo, no? A carousel with a 50-foot diameter makes 1.5 revolutions in 0.5 minutes. Letter A. Find the angular speed of the carousel in radians per minute. Carousel. Ano ba ang carousel? So, carousel yan. And then, diameter. The informations that we know, diameter. So, from this point up to this point. So, assuming na tumama to sa center, no? Center nung carousel natin. Okay, this is your center. So, our diameter is... Ano yung diameter natin? 50 feet, no? 50 feet. Okay, Okay, 50 feet. Next, 1.5 revolution in 0.5 minutes. 1.5 revolutions in 0.5 minutes. So, ibig sabihin lang yan. So, kung andito yung initial starting point nyo, kung dito kayo kunwari naka-position, nakaupo, and you can just sweep out from here, isang revolution. Okay, isang revolution na yun, no? 1 revolution and a half. Okay, 1 revolution and a half. 1.5 rev over 0.5. First thing to do is to convert this into the radian measure. Kailangan nating i-convert ito sa radian measure. Okay, sa radian measure. Kasi basically, ito na si theta natin. Or I mean, this is already our angular speed. Wait lang. Isa-isay natin, no? Isa-isay natin. First things first, ano ba yung equivalent 1.5 revolution in degree measures? Degree measures. So, 1.5 revolution is equivalent to 540 degrees. So, next, ay ko-convert natin si 540 degrees into radian. Saka pa lang natin i-over yung time. Okay? So, 540 degrees is equivalent to ilang pi radians ito? 540 is equivalent to this is equivalent to 3 pi radians. Okay? And then from there, makukuha na natin si angular speed. Angular speed ba yun? Or linear speed? Angular speed. So, we have the omega, no? Paano ba yung omega? Ang pangit ng omega ko. Mukhang omega. We have omega. Ayan. Si theta over time, no? We have 3 pi radian over 0.5 minutes. Or instead of 0.5, gawin natin 1/2 minute. Okay? And you know how to simplify fractions naman, no? Fraction over fraction. So mag-cross multiply lang yan. So that's why most of you answered 6. So our angular speed is equivalent to 6 pi radian per minute. Pwede nyo gawin over minute yan, or pwede rin siyang per minute. Or the symbol per minute. Next. Second problem. Find the linear speed in feet per minute of the platform rim of the carousel. Now, we can already use the relationship between the two. Okay, since we already found the angular speed and we also knew the radius based from the given diameter here. Okay, we can therefore determine, okay, angular speed is equivalent to linear speed is equivalent to angular speed times the radius r. Okay, so this is equivalent to 6 pi radian. 6 pi radian per minute is equivalent to the radius r. What is our radius here? Radius 25, no? From the given 50 feet diameter. 6 times 25 lang yan. 6 times 25, we have 150 feet per minute. Okay, per minute or over minute. Kayo nang bahala kung paano nyo i-denote yun. And you can always write radian, pero since straight line na tayo, no, pwede na natin i-draft yung term na radian, ha? Question.